Good morning. So we are seeing about, I think, which chapter we are dealing. We are now currently with name Hadoop distributed file system. Hadoop distributed file system. So in that Hadoop distributed file system. So last class we discussed about how the distributed system and how the HDFS came into a picture. How the large files are going to be dealt. So why the block size is very large compared to the previous one, and what are the benefits we come to this HDFS system? So what are the major things we will discuss in the last class? So came to this part. This according to our syllabus, we were discussed about this under building blocks of Hadoop. Building blocks of Hadoop. So total we have 5 blocks are there. The 5 blocks, this is the 2, and we have 3 more are there. So the first two in one place and the second 3 in another place. That division also we discussed in the last class. So name node, and along with the secondary name node is there, and another one is about data node, and remaining 2 are about job tracker and task tracker. How we are going to be perform the operations on the data. So overall, I will give a simple information about what we discussed previous. Later on, we will read it one by one line. Then we can clear observation on what is this and what it. So name node will use information about the data. So what type of information means? So when it is created and when it is modified and when it is updated, any data updation is done on the data which is going to be stored, that information only stored in the name node. Information is going to be stored. So information, for example, simply if you click something, so for example, wait a second, I will show you. For example, I have one, for example, simple one document. Some same thing which we are using. So myself, my note, for example. I think my screen is visible to everyone. I think so. Now it is okay. I think. So see here, I have a lot of files are there. For example, if I want to know the name node, it means, for example, simply we can give a property. So what is the use the property? I think it is not visible. One second, I will show you again. Share it again. See here. So it shows, see that, so for example, this is syllabus. So BDA syllabus R1641 is the name, and we see that file type is about document. Okay. So then where it is location, so it is gives the location of that particular file where it is available. What is the size? What is the information? So when it is created on Wednesday, November 18, 2020, and 18:46 a.m. it was created, and latest modified is Friday, September 11, 2020, and 8:42 a.m. it was modified and accessed. So Wednesday, and last accessed when it is, so November 18, 2020 it was last access. So again, what is the information where it is available, details about that one and the previous version, what are, so this is the general information. So what we discuss on a name node, generally when it is created, when it is modified, when it is updated information, the file where it is stored, what is the size of file. So this is the information which we gathered. Based on that, we can track the data where it is available. For example, if I want to know the name node, this is the information I can contact. So data node means, so where the data is available. So for example, where the BDA syllabus where I can find. So see that, for example, if I go to particular folder, so for example, this is the thing. If I open, then definitely the same. So see here. So in a particular folder where it is available. So this is the original file which contains. We can call this is a data node. The information which we provided, that the things known as a name node. So general I explained according to our Windows appendix. But we are doing these thing on a big data sets. So data set, when is it created, when it, where the information, how to access. For example, even if through the data node information, we can write a query and we can access that data. So for that also we can use that data node information is very helpful to process it. Okay. So this is like that. Now we will back to, so these two we got an idea. So name node means, so name node means which gives the information about the data node. So information is like such who is the author, who is the whatever is provided. So when it is created, when it is modified, so how many times it was accessed, even if it will use the log data information also. So that is also is provided by the. So if we want to take this thing, not only with the name node, it's going to be get the help from the secondary name node also. So secondary name node also is going to be part of a name node, and it helps to get these information from the data nodes is properly. It is going to be help to the name node in order to better process the name node information. Okay, so for that only secondary name node. So data node means, so where the actual data is there, there is the actual data is there, that is known as a name node. Sorry, data, that is known as a data node. Data contains, where is the exact actual data is available, that is an. So see here, an HDFS cluster has a two type of name nodes operating in a master worker pattern. So that is we simply call as a master slave in the uh, PPT we say about master slave. Same here also, master worker. So pattern. Name node is the master node and the data nodes are the workers. Data nodes are the workers. The name node manages the file system namespace. The name node manages the manage. So how it is going to be managed? So where it is available, how to access, how to log in, or anything information about the data, that is going to be given by the name node. Name node manages the file system namespace. It maintains the file system tree and the metadata for all files and directories in the tree. This information is stored persistently on the local disk in from the two files, name, space, image. So everything is going to be stored as an image file. So that is images and edit logs, namespace, images and edit logs. So again, the name node contains the two files information. So namespace, image and edit log. The name node is also the data node which contains the blocks, files recorded, sorry, files are located. However, it's not stored the block information, block location persistently, since the information is reconstructed from the data node when the system is started. So when the data is actual data is processing, that time also the name node is going to be helped to reconstruct the information. A client accesses the file system on behalf of the user by communicating with the name node and data node. The client is going to be accessed based upon that. The, the client present as a POSX like file system. So like it is a file system like POSX file system interface. So the user code does not need to know about the name node and data node functions. They simply, for example, client is not going to be get the information. This background process is going to be happen, but if they don't need any information about the file system and data system. They can access the data from the data node and name node, but the when the queries are going to be properly executing, that execute time, so which query, which command is going to be stress the name node, which command is going to be get the data from the data node, that is the internal part of that particular data set. The name nodes are workers of the file system. They store and retrieve the blocks when they are told by. So for example, by client by the name node. Client are the name node. And they reported back to the name node periodically. So we know that how this information is going to be stored. Have you remember the word heartbeat messages? Heartbeat messages. So every 3 seconds, if anything modification is done or anything, everything is going to be heartbeat messages. It is going to be send the information for every 3 seconds. So if you remember the heartbeat messages, that is a meaning simply here. It backs to the name node periodically and with the list that blocks are they are stored, that they are storing. So how it is storing, how what is the information? Okay. Without the name node, the file system cannot be used. In fact, if the mission running the name node were obliterated, all these files on the file system would be lost since there would be no way of knowing how they reconstruct the file from the blocks on the data node. So for this reason, the important to make the name node resilient to failure, and the Hadoop provides the two mechanisms for this. So how the name nodes are going to be important to the access the data, and if something failures occurs in a name node, how to overcome this failure? We have the two ways. One, the first way is to backup. So that is nothing but here we are going to be maintain some replications. So what is the meaning of replications? So keeping the same data in a different places. If any one location the data is missing, we are going to be get the data from the other places. So whenever the server is going to be failure, so latency is occur or node failure is occur, something has happened, we are going to be get the exact data from the other nodes. That is it. The first way is backup the files. We make up the persistence, start the file system metadata. Hadoop can be configured so that the name node writes the persistent state to multiple file systems. These writes are synchronous and atomic. Atomic means single. The usual configuration chooses to write the local disk as well as in a remote MFS network file system mount. So remote file system, network file system mount is going to be take place to write the same data in a different places. So it is also possible to run the secondary name node. So I already know that if any name node is unable to get the information or unable to process, so that time we are going to be have a help of the secondary name node and it is going to be processed and it is going to be get the data from it. Okay. So which deputes its name node does not act as a name node, but it is not act as a name node. It's going to be just help. So its main roles to periodically merge the name node namespace images and the edit log to prevent the edit log from becoming too large. So that's why when it is difficult to manage the name node, so that time only the failure occur. The name node is going to be failure when, so name node it is going to be maintained. So the maintaining is something is going to be happen critically. Some failures occur. So that is it may be a large logs will be happen. So that is a periodical changing is happening very high. For example, even if now we can see that previous thing we discussed about the NCDC data, weather set data. So how many sensors are there? Is periodically updating the data. So if whenever it is updated, it's automatically the data node need to pass the information to the name node. So the changes is happened, then only we can know that the change. So that's only if the large data is there to manage and modify. So that time we need to get any help from the secondary. So it is going to be merge the that is namespace images and edit logs to prevent the edit logs from the being too large. The secondary name node is usually run on a separate physical machine. It's going to be run on separate physical machine since it requires the friendly of CPUs and much memory as the name node to perform the launch. It keeps a copy of merged namespace images which can be used in the event of name node failure. However, the state of the secondary name node logs that of primary. So, in the event of total failure of the primary, the data loss in the almost certain. So, in the minimum loss we can have. But usually, the course of action in this case to copy the name node meta files on the NFS network file system to the secondary name node to run as a new primary. So we are going to be have some of the new primary systems. What happened? Anyone requesting or changing any information? We have a problem. Okay. So that is the next concept is about HDFS federation. What is this federation? So the name node keeps an information to the every file and block in the file system in the memory, which means that on every large cluster with many files, memory becomes the limiting factor for scale. So HDFS federation introduced in the 0.23 release series, that is the next version. It allows the cluster to scale by adding a name node, each of which manages a portion of file system namespace. For example, one name node might manages all files rooted under user. So the slash user. So we know how the for example, URL, how it will be there. Same, the file system URL, this is slash slash we are going to be using. No? So that also I will show you. One document how will be C colon slash program file slash slash something, same way. Remoted under slash user. Say, and the secondary name node might be handle the users under shell. So it is the main. We already told that the secondary name node is going to be run on separate mission. So when it is a shared mission, it is going to be there. So under federation, each name node manages the namespace volume, which made up of the metadata for the namespace, and the block code containing all the blocks for the file in the namespace. Namespace volumes are independent of each other, which means name node do not communicate with one another. So one name node is not going to be communicate with another name. So we don't have any communication. So and furthermore, failure of a name node is not affected with the availability of namespace managed by the other name nodes. So if any one name node is going to be failure, it is not going to be effect on other name nodes. So that is also. So block pool storage is not a partitioner. However, so damage registered with each name node in the cluster are stored the blocks of multiple blocks pools. So the pools means information is large. So we can okay. To access a federated HDFS cluster, client uses the client-side mount table to map the file paths to name node. This manages the configuration using the view file system and view fs/url. So we know that we can access this one through local file system or the web also. So through that web we are going to be use view fs/url, and general we can use view file system. Okay. use that whether it is done properly or not. Another one is about HDFS high availability. So why it is very high availability? The combination of replicating name node metadata on multiple file systems. So see that this line is very, very important one. So the combination of replication name node metadata on multiple file systems and using the secondary name node to create a checkpoint protects against the data loss but does not provide the high availability of file system. Does not provide the high availability of file system. The name node is still a single point of failure. Since it did fail, all clients, including the map reducer, would be unable to read, write, or list files because are you getting any noise? Can someone answer? Are you getting any noise?
No, sir.
Asuna?
Noise and less, sir.
Nameless. Okay, thank you very much. Since it did fail, all the clients, including MapReduce jars, would be unable to read and write. So whenever it fails, that means simply. So we told that there is no communication between the name node to name node. We don't have any communication. If any name node failures at any point of view, so the failure, how it is going to be identified means, so we are unable to read and write on the name data node. So we are unable to process, we are unable to view, we are unable to see it is what is the data. So we are unable to process these heartbeat messages. If it is going to be like this, that means we are not going to be doing something is not going to be happen properly with that name node. So that is a single point of failure is happening. So that is because the name node is the sole repository of the metadata and the file to block mapping. So that is the sole responsibility, own responsibility. So have you heard the word this sole proprietorship? If I may have heard the partnership and sole proprietorship. We have heard these terms. In such an event, the whole Hadoop system would effectively be out of service until the new name node would be brought online. The new name node could be brought online. To recover from failure name node, in this situation, the administrator start a new primary node. So if that is name node is failure, he is going to be start with a new name on the file system meta replicas. Replicas means we are going to be getting the data from the other servers, so other locations, and configure the data nodes and clients to use these new name nodes. So why we are getting means again we are going to be configure and we can request. The new name node is not able to serve a request until it has loaded its namespace images into a memory, replied its edit logs, and received enough logs reports from the data nodes to leave the safe node. On large clusters with many files and blocks, on a large cluster with many files and blocks, the time to taken from the name node to start from would be take 32 or more minutes. So that is simply we can say this is about the recovery. So we are saying that if name node is going to be failure occurs, that is a single point of failure is occurs. so that we are going to be get that name node information from the other servers or other location. So that is simply known as a replication. So that is simply known as a replication. If you are going to be get, so that total data you need to recover, it may take 30 or more minutes. So how much time? So that is it's going to be about how if it is a failures, how it is going to what is the heading? High availability. How we are going to be get the availability. The long recovery time is a problem of routine maintenance too. In fact, the unex- unexpected failure. So that is the unexpected failure of name node is so rare, so rare. So generally it is not going to be happen. If any unexpected, it is going to be. In case we are planned to downtime, the actual more important in practice. So general it will be. So the release, the 0.23 release series, Hadoop reminds remedies this situation by adding the support of HDFS with high availability. So even if these rare conditions also we need to overcome, the 2.3 release series is going to be overcome on this by using the high availability. This implementation, there is a pair of name nodes in an active standby configuration. The event of failure in active name node standby, it takes over its duties to continue servicing client requests without a significant interruption. So a few architectural changes are needed to this to happen. So how these high availability is changing. So general, we are going to be configure whenever we are going to be configure, we need to follow some of the following steps. The name node must be high available, require high available shared storage to share edit logs. We know that the two parts of name node, no? That is namespace, that is FS images, and the second one is a edit logs. So in the initial implementation of high availability, that is HA is high availability, this will require an NFS network file system filter. So, but it is a future release, more options will be provided, such as bookkeeper. So we know that another advanced application of this. So based upon the Bulletin Zookeeper. So we know that this pig Apache Latin, so that is Apache pig and Hive Apache Hive, and we have Snooker. Again, these Zookeeper, all those things are applications. So that is there is like a versions how it will be. I mean, simply we can say that we have an Android versions now. So 6.1, 6.2, 7, 7.1, 9, 9.2, 10, how it will be. Same here also. When it is standard by name node comes into it, it reads up end of the shared edit logs to synchronize its state with the active name node. When it is continues to read new entries as they are written by the active name node. Data nodes must send the block report to both name nodes since the block mapping are stored and name nodes memory and not on the disk. Client must be configured to handle the name node failure with the uses a mechanism that transparent to the user how it will be and the failure how it will be happen, everything is going to be shown as a transparent. So if it is an active name node page, then the standard standby it can be over standby over every quickly in a few tens of seconds since it has a latest state available in the memory. So both the latest edit logs entries, that is a edit logs is when it is failures, that is immediately latest entry, and it up to date block mapping. So the actual observed failure time will be longer in practice, around We already know, but the previous is 30 minutes, around it's a minutes and so on. And so since the system need to be conservative in deciding that the active name node has failed. So very initially very fast we are going to be getting. So in the unlikely event of standby being a down when the active falls, the administrator can still start with the standby from the cloud from code. So this is no worse than non-high availability case. So it is not going to be happen if it is the high availability is there. And from an operational point of view, it's an important improvement since the process is a standard operational procedure built in Hadoop. Okay. So then failover, the same thing only failover and fencing, how we are going to be keeping. So failover and fencing. Fencing means how we are going to be protected. So failover, if how the name nodes are going to be failed. The transaction from the active name node to the standby, managed by the new entry in the file. New entry in the system is called failover control. Failover controls are pluggable. Pluggable means just we are going to be run it like a pen drive. So, but it is first implementation uses the zookeepers to enter zookeepers to ensure that only the name nodes is active. Each name node runs a lightweight failure. So lightweight means it is simply we can call it thread. So lightweight process on the processor is going to be a thread now. So like lightweight failure control process whose job is not to monitor its name node for failures. Using a simple heartbeat mechanism, the trigger a failure should name node false fail. If something will happen, so the trigger will failure should be a name node should be get failure. So that is a heartbeat mechanism. Again, whenever some particular information not going to be gives an immediate response. So then definitely if any one log is missing, for example, any particular data is modified, any data is changing, it is not going to be mentioned by the name node, then it is a single point of failure only. So if such type of failures occur, trigger failures occur, should maintain name node fails. Fail Failover may also be initiated manually by an administrator. In this case of routine maintenance, for example, this is known as a graceful failure. Since the failover controlled arranges an orderly transaction for both name node to switch roles. So how it will fail? In this case, the ungraceable failure. However, it is impossible to be sure that the failure a name node has stopped running. So whenever the failure occurs, immediately we are going to be stop that particular name node. That means, for example, after failure, we are going to be get back with another name node, which is we are going to be get it from the application. So in between any data updation is changing, then definitely it is going to be have a problem of some data is going to be missing. So whenever any initial or grace, something, what is the meaning of grace means? Maybe so this, something is happened in high level or low level, whatever it may be. So it is going to be happening immediately. We are going to be stop and we are going to be processed immediately with the new one. So in order to get a new data loss. Okay, for example, the slower network or network partition can trigger a failure transition, even though the previously active name nodes still running and thinks it was still active name nodes. So that is if is running on the same failure active name nodes. So that's all. even though the previous name node is still running and thinks it is active name node. The high availability implementation goes on great lengths to ensure that the previously activated name node is prevented by doing these any damages or causing corruption. The method is known as fencing. So high availability we are going to be taking a part of that. So how we are going to be getting the information clearly without any corruption or any loss. This is known as about fencing. So two things we are observed here. What is fail, failure over, fail over, and another one is about fencing. So fail over means if name node is going to be failures. So how we are going to be wait for the information to be submitted to the second one. So whenever failover is occurs, then the fencing is about whenever the failure occurs, we immediately stop it and we are going to be get access the same name node information from the others, and we are going to be adding the newly added data to the previous one without having any loss. So here in the part where how the high availability is going to be implemented in a long ensure that. So in order to avoid the corruption of this. So this is known about fencing. So this system, the system employs a range of fencing mechanisms, include the killing the name nodes process and revoking its to access to share the storage directories. So typically via by the vendor specific network file system command, and the disabling the network ports via remoting management commands as last to resort. So the previously active name nodes can be fenced with the techniques rather than the graphically as known as notice or short the other node in the head. The smooth the meaning is short the other node in the head, which uses the specialized power distribution unit to forcibly power down on the host nation. So whenever, so other point of view, whenever we can call when it is going to be, for example, if I am going to be do the transaction in between, maybe our network is going to be disabled immediately, it come. Or something is a power problem with the consumption power problem. So in between the transaction, maybe power failures occurs. Maybe it is our system or the receiver system. Anyway, any one point of view it is missing, it is totally it is going to be get the host machine. So power failures. The client failover is handled transparently by the client library. Simplest implementation uses the client-side configuration to control over. The HDFS URI uses the logical hostname which mapped to a pair of name node address. Which mapped a pair of name node address. So in the configuration file and the client library ties each name node address until the operation succeeds. Until the operation is succeeded. So we know I already told you in the last class. Please be get back to your the command line interface. What is it? So we are going to look at the HDFS by interacting with it's the form of command line. There are many other interfaces to HDFS. Command line too, and but the command line is one of the simplest and many developers is the most familiar. We are going to run the HDFS on one machine. First, follow the instructions by setting the Hadoop pseudocode distribution. We know that local and pseudoco and fully distributed. So three types are there. So here we are mostly we are going to be talking about pseudoco distribution mode only. So later we will see on the running on the cluster mission and use the scalability and fault tolerance. There are two properties that we are setting a Hadoop that is pseudoco distribution, distributed configuration. Pseudoco distributed configuration that deserves further explanation. For the first, we can do fs.default.name set to hdfs colon localhost, which is used as a default file system for the Hadoop. File systems are specified by URI and and here we have used the HDFS URI to configure the Hadoop to uses the HDFS by default. The HDFS demands will use these properties to determine the host and port for the HDFS neighbor. We will be running on the local host. We obviously we know the other two. We may running on local host. On the default HDFS port is 8020 and the file system latest one we are going to be 9090 latest we are going to be talking about the last weeks. So in the Hive HDFS Hive that is Hive commands where we are going to be run. Either we are going to be run on terminal mode or we are going to be run on website variant and also URL based also browser variant also we are talking. Whenever we are going to be access the port number here 9090 something we are going to see the last. Sorry, host clients we will be property to work out where the name node is running so they can connect to it. So we set the second property DFS dot replication so that is the HDFS does not replicate the file system blocks. They are default factor of 3. So we know that the default replication size is 3. When the running a single data node, the HDFS cannot be replicated the blocks of 3 data nodes. So it is would be perceptually one about the blocks being under replicated. So these settings solve this problem. How it will. So basic file system operation. So the file system is ready to use and we will do all the usual file system operations such as reading files and creating directories and moving and deleting data and listing directories also. So we can type hdfs space fs space hyphen that is help. We will get details about the commands of it. We start over copying the local file system HDFS. So how it is copy from local system to so HDFS local system, how we are going to be copying. These commands invokes the HDFS file system shell command fs, which supports a number of subcommands in this piece. We are running a copy from local, copy from local. A file quantable. So dot text is copied from the user dot com dot ang. So that is the names of a particular system of quantable dot txt on the HDFS on running on the local host. In fact, we could have omitted the schemas on the URI to pick up the default. HDFS slash localhost is specified in port site.xml. So we have port site.xml, HDFS.xml, and we have various XML files also we need to install. So if you remember, you can use the better. So port site.xml, we have various types of XML files also we are going to be found. So these are the configurations again. So how to do the message digest. So we are going to be sending the data. Message digest means we can have a hash function. Hash function means how we are going to be do the message in a proper segmentations in a fixed size. Then how the file system will be there. So file system local, and URI schema is a file, how it will be Java implementation of that local system. So a file system is locally connected disk with client side checksum. Uses the raw local file system for a local file system which no checksum. See the local file system on page. So we see the page number 84. We can look at that. And HDFS means HDFS dot distributed file system is sometimes. So HDFS distributed file system, HDFS is designed to work efficiently on conjunction with the MapReduce. Then another one is about HFTF, HFTF file system. The file system is provide read-only access to the HDFS over HTTP. So when we are running on the browser, so we are going to be get the only readable files. How we are going to be getting? So that is the reading only. We are not going to be changing anything. So that is despite its name, HFTF has a no connection with FTP, often used with that is the distributed TCP, the parallel connection. To copy the data between the HDFS clusters running on different versions. So various versions are there. How the HFTS and website, web HDFS and KFS, various file system manners are there to implement these. So how the interfaces are there. So accessing the HDFS to HTTP, how we are going to do access. This thing is not here. Even when we are going to receive, you can see that. Actually, we are going to be follow, you can see. So we have to know about how the Java interface works, because we are going to be running from the starting onwards. So that is a distributed file system. So previous one pseudocode and distributed local system, pseudocode and distributed file system. We are going to be installing in 3 different ways. So most of the here how we are going to be running the command. So the next chapter we have about HDFS into collector that we will start in the class. Okay. So anyone having doubt, you can ask me. I think, have you accessed that book which I shared to you? Have you accessed or not? So I shared all the PPT and the book also. So please go through the book and you can get access easily. And you can know that. So anyone having doubt, you can ask me. Thank you. We'll see you in the next class.